video introduces how to use BrainCog to implement the quantum superposition inspired spatio-temporal encoding method. Despite advances in artificial intelligence models, neural networks still cannot achieve human performance, partly due to difference in how information is encoded and processed compared with the human brain. In BrainCog engine, we build a brain-inspired quantum superposition spiking neural network. Different from the traditional artificial neural network, the complex cognitive function of brain stems from a complex structure with neurons and network connections on the other hand, and its powerful information encoding abilities on the other hand. Previous studies have well demonstrated that introduction of quantum computing can accelerate the information processing of artificial intelligence models, but we hope to find another way to enable neural networks to gain unprecedented capabilities through the introduction of quantum theory. In this paper, we propose the quantum superposition inspired spiking neural network. We propose a quantum information-inspired encoding scheme of neural spiking frequency information compared with spiking neural networks, like in the representations in these videos and the equations in these papers. Based on the principal quantum information, the background involves the picture is encoded in the form of quantum superposition states like in the figures, which is further transformed into neural spiking trees of different phases and frequencies, like the finger E in this picture. The QSSN incorporates quantum theories with brain-inspired spiking neural networks models from computational perspectives, resulting in more robust performance compared with traditional AI models, and especially when processing northern input like the background involves the image. You can see from this paper that the QSSN model can achieve better performance in the background. Reverse the pictures and the noisy image dataset, compared with the traditional deep convolution models like VGG, ResNet, DisNet, and some same models. The quantum image processing combines quantum image processing method can encode our original information and complex information into superposition state. The complex information in quantum encoding is similar to the information processing in the spiking information processing in the brains, which also include the phase and the rate dimension encoding method. Neural spikes can encode spatial information with specific spiking rates and spiking times. This can be used to represent quantum information. And in this work, we use multi-component neural models to process the quantum information encoded in the spatio-temporal spectrums, and the multi-component spiking neural network, including the models, somatic part and dendritic part of biological neurons. And we also propose the training method and training method about the multi-component spiking neural networks, and also you can find the quantum superposition inspired encoding method in the BrainCog engine We implemented the QS encoder class in the BrainCog encoding modules. It implements the quantum superposition state image encoding and the transferring of spiking different spiking trains with different phase and rate. Also, the multi-compartment neural network can be found in the QSSN passing files. It's in the model zone. This net class implements the a three-layer multi-compartment spiking neural network, including the hardware layer and output layer. You can use the multi-compartment neural model and QS encoding separately, and also if you want to reproduce experiment results in the paper, you can run the main passing files in the examples QSA modules. It will train the model in the original image and test it on the background reverse image dataset. Okay, this is all about how to use the BrainCog engine to implement quantum superposition encoding method. And thank you for your listening.